Hello, let's continue our Sudoku adventure with Caged to the Max by Strosahl. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have killer cages in the grid. That's these cells surrounded by dotted lines. First of all, digits can't repeat in a cage. So if that was 2 and that was 2, that would violate our cage rule. Even though Sudoku's happy with it, the cage is not. So that's not allowed. In addition to that, the digits inside the cage all sum to the value on the top left. So if this was 1, 2, and 6, 1 plus 2 plus 6 is 9. That would be one way to fulfill this cage. In addition to that, we have these red cells in the grid with greater than signs. They have to be bigger than all the cells that share an edge with it. So if this was, for example, a 4, we could do 1s and 3s and 2s and maybe another 1. But what we can't do is put a 5 or a 6 because these, all 4 of them need to be smaller than this one. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so these are all 3-cell cages. If we think about 3-cell cages for a second, a good thing to start thinking about is what is the minimum that they can add to and what is the maximum a 3-cell cage can add to. Well, the minimum is going to be 1, 2, 3. And 1 plus 2 plus 3, a nice little mental math trick for you is if you have 3 consecutive digits, their sum is the middle digit times 3. So 2 times 3 is 6. So 1, 2, 3 adds to 6. So 6 is our minimum. We don't have any cages at the minimum. 4, 5, 6 is our maximum. 3 times 5 is 15. So 15 is our maximum sum. This is 15. So that's what we have to do. When you're at the minimum or maximum, there's only one way to do it. You have to be the minimum or the maximum. Makes sense, right? Now this, I notice, is bigger than these two. So this has to be a 6 because it's the largest of the 3. And this ends up being a 4 or 5 pair. So why don't I bake that in? So these digits all see the 4 or 5 pair because they see it either through the box or through the column. Box or column. And so these are from 1, 2, 3, 6 because they're not 4 or 5, and this can't be a 6. In fact, we can't put a 6 at all in this 9 cage. This 6 sees the whole thing. So one of these is another 1, 2, 3. The other is a 4, 5. Does anything not work? Does the 3 not work if we need? No, we could do 1, 3, 1, 3, 5. Okay, I don't know that I can do anything with that right now, so let's not worry about it. Maybe we should just think about, we have a lot of these maximum digits in these cages. They have to be the biggest of the cage sum, right? Just like we did here. So 8, for example, we know it must contain a 1. This is definitely not going to be a 1. It has to be bigger than all the other ones. But what are the ways to sum to 8? That's the way to start. So we know it contains a 1. The other two add to 7 without the 1. So we can't do 1, 1, 6, right? But we can do 2, 5, or 3, 4. So this is from 4 or 5 only. There is no 6 in an 8 cage, so actually the 6 gets placed here in that cage. So the 8, 4, 5 is the maximum. No 6s here. Not sure if that's helpful. All right. Maximum for 9, we can put a 6. We can also put a 4. 2, 3, 4 works. So 4, 5, 6. We're either 1, 2, 6, 1, 3, 5, or 2, 3, 4. So 4, 5, or 6 is the max. This is definitely not going to be a 6 because it's smaller. In fact, I know that 9 cages have 2 digits for 1, 2, 3 and 1 digit from 4, 5, 6. Easy to prove. If we had all 3 digits from 1, 2, 3, we would add to 6. We'd be 1, 2, 3 triple. If we had only 1 digit for 1, 2, 3, our minimum would be 1, 4, 5 because we'd have 2 digits for 4, 5, 6. So the absolute minimum would be 1, 4, 5, which has to 10. So as a result, 2 1, 2, 3s and 1, 4, 5, 6. 10 cages cannot have a 4. The biggest we could add to is 2, 3, 4, which is only 9. So this is 5 or 6, but it's not a 6. So that's a 5. These two add to 5. So they're from 1, 2, 3, 4. This cell here sees these two 1s. Wherever the 1 ends up in this 8, it sees it. So that's not a 1. In fact, what can these be? I think these definitely are from 1, 2, 3. We're either 1, 3, 4 or 1, 2, 5. Oh, that makes this a 4. So these two add to 4. That's a 1, 3 pair. And so this is from 2, 5, 6. This is not a 4, so that's not a 1. I guess we already knew that wasn't a 1. Okay. 3 pair. What about this 11? Oh, how about up here? This is not a 4. So this actually has to contain a 1 now. Because if it was 2, 3, we'd have to do 2, 3, 4. So it contains a 1. So that one's not a 1. 1, 2, 3, 1, 2, 4. I feel like the 4 is limited here. Yeah, where's the 4 in this row? That's crazy. Oh, right. It's a little easier to see if you use banding. Yeah, so these are this box. These aren't 4. This isn't 4 because of the 4 or 5 pair, and this isn't 4 because of the 9 sum. And so this is our 4. That makes that a 5. Now, what do we get from that? Well, let's think about this 11. We haven't thought about the 11 yet. It can't be 5. It definitely can't be 4. So the biggest digit's going to be a 6. That makes that a 5. So to get to 9, we need 5 plus 4. So this has to be 1, 3 pair to get us the 4. So that's not a 3. This is only a 2. That's 2 and 6. That's a 6. Clean up the 2. Clean up these 6s. This whole column just needs 1, 3, 5. That's not a 5. So this has to be the 5. So these two add to 4. They're a 1, 3 pair. So this has to be a 2, and that's our 1. So 1 plus 2, yeah, 1, 2, 5 gets us to 8. That's 2 and 5. That can't be 2, and that can't be 1. So this can only be a 2, 3 pair. And so that's 3, and that's 2. That's 1, 3, and 1. Hopefully I'm doing this right. That's the 3 and a 1. That's 1 and 3. I always worry I got a sum wrong, and I'm just doing the wrong puzzle, basically. This is a 4, and this is a 2. Up here I need 1, 3, and 4. So this is the 1. This is the 4. This is the 3. Good, that adds to 9. These two digits, we need a 4, which goes here, and a 6. Looks like we're finishing. So here we need a 2 and a 4. So that's 4, that's 2. And this digit's a 3, and we're done. And 2, 3, 6 is 11. All right. Nice, cool puzzle, Strosahl. I enjoyed the concept of, hey, this is the biggest digit in the cage, which restricted that digit, and it restricted the other two to not be the biggest digit. That's a cool idea. I think is there a constraint that just specifically does that? I have it deep in my memory. There's some constraint that just says this is the biggest digit of the cage, but I'm not sure. Anyway, how'd you do?